Hey, so welcome everybody. It's our first education session of our AR/VR hackathon. We're pleased tonight to have April. Oh, April, I didn't even really ask you for your last names. Spite? Spite?
Spate.
Spate. Oh, that's close. So April Spate with Microsoft is going to give us a presentation on developing in mixed reality with an emphasis on, surprise, surprise, Microsoft HoloLens. So with that, April, I'll turn it over to you.
Yes, hi everyone. My name is April Spate. I'm a senior cloud advocate at Microsoft on the spatial computing technology team. And I would say for me personally, I span across various different areas as it relates to our products that we have for mixed reality. My main focus is with the mixed reality toolkit. And so that's one of the things that I'll be sharing today during the presentation. But I have done work with Azure Digital Twins as well, and Azure Remote Rendering too. So as we're going through the presentation, feel free to leave questions in the chat and I'll answer them. And then we'll also do a live Q&A afterwards. I will do my best to answer everyone's questions that come through. And if I don't have an answer, I'll connect with the product team to get an answer for you as well.
And I'll say April is not a master multitasker. So we're actually doing a recorded session. So we have the presentation so that she's also available at the same time to answer questions while you post them in chat. So with that, I'm going to start.
There, I got it.
All right, welcome, Jeff. So as I said, good to work those issues out now before the next hour. So, and let me make for sure I can share this successfully.
My name is April Spate, and I'm a senior cloud advocate.
I hear me.
Oh, wait.
Today I'm going to talk about how you, as developers, can build apps with the updated
Everybody's hearing.
devices and services that Microsoft has introduced to enable
It's a little low. I'm not sure if it's the same for anyone else.
experiences. We'll first start with defining what is mixed reality, followed by an exploration of what we have to offer as part of our tech stack. Finally, we'll head into a step-by-step tutorial of how to set up your computer for Windows Mixed Reality development and create a Hello World app using the Mixed Reality Toolkit for Unity. I'll mention various resources throughout this presentation. All links to those resources will be shared at the end of this workshop. Let's get started. So,
I think we went mute unless it's just me.
No, I can't hear it either.
Oh, okay.
Probably me. I think I have to be unmuted for you to hear. So I'll leave myself unmuted.
Could you go
hear
back
now?
a little? Yeah, just a bit. Could you go back a little bit on what is mixed reality just before I introduce that? Yeah, probably about there. Yeah, we can start here.
All links to those resources will be
Just
shared.
turn it up just a bit as
Let's get
well.
started. So you hear us talk about mixed reality, and I would like to briefly explain what mixed reality is. Mixed reality is the blending of the physical and digital worlds. You can also think of it as a spectrum that spans across the physical world on one side, all the way up to the digital world on the other side. From immersing ourselves in digital creative worlds to digitally enhancing our physical world, mixed reality is a spectrum that includes all of these possibilities, from augmented reality to virtual reality and everything in between. Mixed reality empowers us to break free beyond barriers. Here are some examples of augmented reality and virtual reality products, from Hololens to Samsung Odyssey to mobile phones. Let's go over our tech stack and what we have to offer to you all. We believe that mixed reality is the next wave of computing that will drive significant business value and impact and has substantial market potential. To enable you to take advantage of the promise of what this technology and market opportunity has to offer, we are investing in a full stack approach towards this category. Although we provide cross-platform support, today we'll mostly focus on the HoloLens 2. However, we believe that we need more than devices to build great solutions where we can unlock ourselves in 2D screens and make the world your app canvas. We've created Azure mixed reality services such as digital twins, spatial anchors, and remote rendering. And with the power of our Azure Cognitive Services, you can extend your mixed reality apps so they have human-like intelligence by using services that are packaged as RESTful endpoints for an easy X-platform consumption. All right, so let's go explore the HoloLens 2. So here we have the HoloLens 2. On the front half, we have a visor that can flip up and down. And then on the back half, we have a dial that you can turn to help adjust for fit. Let's take a look at some of the different features of the HoloLens. I'm going to start with fully articulated hand tracking. So immersion is about more than just the visuals though. You can touch holograms by just reaching out with your hands. Fully articulated hand models are amazing because it lets you do what feels natural. You and I can both pick up a cup slightly different. And instead of enforcing one way or another, we're letting you do it your way. This is so important because you let workers do what's natural to them and just reduces the learning curve and makes them immediately more productive. Furthermore, with such a detailed model of the hands, we now open opportunities around training, allowing you to interact with the training task as you would the real thing. Next, we have spatial mapping. Additionally, the new Connect sensor on HoloLens 2 lets the HoloLens create a surface mesh of your physical environment that is more detailed than on the original HoloLens. This lets your digital content interact even more realistically with your physical space. This also provides the additional data that the HoloLens 2 needs to better understand and use your user's environment. And then there's the Azure Connect. The depth sensor is effectively a fourth generation of the Connect sensor, a best-in-class time-of-flight depth sensor. We fit this very capable sensor for hand tracking and spatial mapping into a headset. We also heard customers wanting this capability in a standalone device. So we created the Azure Connect device as well. And then there's Windows Hello and eye tracking. Our next innovation helps get users into the flow faster, more securely, and across shared devices. Windows Hello uses iris recognition, one of the most secure forms of biometrics, to authenticate the wearer. This means no more typing passwords. This incredibly secure and convenient login is available with HoloLens 2 and Azure Active Directory. The second thing eye tracking enables is per-wear optimization of the displays. We know the position of your eyes in space, so we can present the best aligned and accurate image to your eyes. Lastly, we get into a bit of mind reading with gaze tracking. This is like a window into the mind as the eyes provide context for not just an action, but also intention. By enrolling in Windows Hello, the HoloLens 2 can detect who is actually wearing the device, automatically adjust the IPD for that user, and sign them into their accounts on the device. This can also be tied to their Azure Active Directory settings for increased device security. This happens on the fly, so even if you share a device with other users, the HoloLens will make sure the right permissions are in use. And your users always have the device settings correct for the best experience possible. Let's now explore our mixed reality services. We're going to start with Azure Spatial Anchors. You can now create multi-user mixed reality applications across Microsoft HoloLens, iOS, and Android. This is designed to help you securely deliver 3D data and digital content in the real world with mapping capabilities like wayfinding, all to increase efficiency, collaboration, and confidence for your teams and customers. There are challenges that have prevented mixed reality experiences from being accessible for businesses and developers everywhere. Insufficient security and no cross-platform collaboration. Security is a wild west. You can't tailor solutions to your business needs, and it's hard to make solutions accessible to your entire workforce, no matter their device. There are also legacy environment and industry pain points, a workforce that needs information in situ in the context of their physical environment. A challenge in developing spatial systems is finding a common reference point in space which lets us build collaborative experiences. For example, as a human, it's easy to tell someone to stand about 1 meter in front of a passport scanner facing towards it. It's not so easy to get different devices to understand that sort of reference point. Azure Spatial Anchors equips developers and businesses with our best computer vision and spatial intelligence, all while taking time-intensive backend engineering off of their plates, so they can focus on what matters, coding customers, building mixed reality applications made for collaboration over time. Using our managed service and client SDKs, customers can enable cross-platform and multi-user experiences, wayfinding, and persistent digital content in the real world. Mixed reality belongs to every developer in every business, and we're helping customers bring mixed reality to devices that best fit their solution. Azure Spatial Anchor supports HoloLens, iOS, and Android apps built with Unity, ARKit, R4, and Microsoft's Universal Windows platform. And next we have Azure Remote Rendering. Experience 3D without compromise to fuel decisions and design efficiency. Remote rendering is a service that renders high-quality, interactive 3D content and streams it to your devices in real time. Enterprises like PACCAR, a global leader in commercial-grade vehicle production, work with complex 3D assets every day. They are eager to use mixed reality to improve business outcomes, but they are blocked by the inability to render those complex 3D assets on devices like HoloLens and mobile phones. The computing power on these devices simply isn't enough to render complex assets at full quality. Enterprises currently need to decimate their models and simplify them enough to run on target hardware. This simplification can result in a loss of important detail that is needed to make key business and design decisions. Mixed reality generally involves low-powered mobile devices with mobile-class CPUs and especially GPUs. If you have big, complex models, then a mobile GPU is going to struggle to display them without some pre-processing that is going to lose you some fidelity. Remote rendering uses powerful GPU machines in Azure to render the most complex models and stream them in real time to remote edge devices. It is optimized for high-quality content, leverages multiple powerful GPUs simultaneously, and avoids decimation or other quality reduction. In scenarios where every detail matters, industrial repair or plant management, design review for assets like truck engines, preoperative surgery planning, and more, 3D visualization brings that detail to life. Remote rendering helps designers, engineers, doctors, and students better understand complex information and make the right call. Next, we have Azure Digital Twins. Now more than ever, context is everything. Data is no more than numbers if we cannot understand and act on it within the demands of our daily physical environments, be it a conference building, a hotel, or a manufacturing facility, just three of many. Azure Digital Twins is a platform that enables our partners to build digital twins that offer spatial context to the IoT devices that they have connected by modeling the relationships between people, places, and those devices. It's a powerful component of mixed reality solutions. Accessing building and IoT data can be difficult in complex and active environments, like industrial facilities and large spaces such as hotels, conference halls, etc. We have a new learning path on Microsoft Learn in which you can learn how to create a mixed reality HoloLens 2 application using Azure Digital Twins and Unity. The example project is a windmill farm that pulls real-time turbine data using the Azure Digital Twins service. And finally, we have Azure Cognitive Services. These enterprise-grade services allow you to use the sensors on your edge devices to understand the people around you. Whether you need to understand how someone might be feeling, hear what they are saying, translate speech between two or more languages, or do some deeper computer vision tasks, Azure Cognitive Services provide an easy, flexible, tested path to doing so. The APIs can be combined, like building blocks, to infuse AI into your mixed reality apps to take advantage of people, places, and things. From a mixed reality app perspective, you can leverage cognitive services for vision. So from faces to feelings, you can allow your apps to understand images and videos. For speech, you can hear and speak to your users by filtering noise, identifying speakers, and understanding intent. Also language, you can process text and learn how to recognize what users want. There's also knowledge. You can tap into rich knowledge amassed from the web, academia, or your own data. We also have search. You can access billions of web pages, images, videos, and news with the power of Bing APIs. And then finally, we have labs. Lab is an early look at emerging cognitive services technologies. You can discover, try, and give feedback on new technologies before general availability. Here we have some of the platforms and tools that you can use should you decide to develop for mixed reality. The mobile era of computing is comprised of closed ecosystems. As leaders in mixed reality, we want the third wave of computing to be different. We want the future to be open. Build with the tools you choose. With built-in HoloLens 2 support, you can use popular development platforms such as Unity, Unreal, and Euphoria to create your mixed reality experiences. We believe in an open API surface and driver model. We'll continue to support open standards such as Chronos and OpenXR. For this workshop, we'll focus on Unity and the Mixed Reality Toolkit. The Mixed Reality Toolkit is an open source cross-platform development kit for mixed reality applications. MRTK version 2 is intended to accelerate development of applications targeting Microsoft HoloLens, Windows Mixed Reality Immersive VR headsets, and OpenVR platform. Android and iOS device support is also available. Although for this workshop, we'll focus on Unity as our engine, you could also use Unreal as well. We have separate documentation available should you choose to go the Unreal route. Here we have the features available in the Mixed Reality Toolkit. Learning to build for mixed reality is different than building for mobile, gaming, or productivity apps. You need to think differently about your inputs, interactions, and user design. We've taken developer feedback and rewritten the Mixed Reality Toolkit to be a performant, cross-platform set of tools and resources to help you build applications that solve your customers' problems and help minimize the need for rewriting the same boilerplate code each time. So without further ado, let's head into Unity and get started. The first step to get started is to ensure that you have all the proper tools installed. We have documentation, which states all the tools that are necessary for Windows Mixed Reality development, and we've included a checklist as well. Within this checklist, you'll find that you need Windows 10. You'll also need Visual Studio 2019, and that's going to be 16.8 or higher. Next, you're also going to need Windows 10 SDK. And although we do list the HoloLens 2 emulator here, since you're using Unity, you can instead use the Unity editor to test out your apps. In addition, you'll need to ensure that you also have Unity downloaded and installed as well. And we'll be doing our work in starting the project at least from the Unity Hub. And the final thing that you're going to need is the Mixed Reality feature tool. And I'll get into that in just a bit. But for now, let's go set up the project in Unity, and then we'll come back to the Mixed Reality feature tool. So here on my desktop, I have the Unity Hub open. To create a new project, you're either going to select New, or click the drop-down that's here and select the version that you would like to use. I'm going to select New. That'll default to the version that's my most recent. As for your templates, you're going to select 3D, and then you're also going to fill out a project name. I'm going to name this one Hello World. And then you'll also select the location for your project. I prefer to keep mine within a convenient folder that's labeled Unity with all my Unity projects. However, find a place that's convenient for you. Once you've done that, you're going to click Create. And then Unity will begin to create the project. Once the project has been created, Unity will open with the Unity editor. So now that I'm in the Unity editor, you may notice that my view might look different than yours. That is because of the way that I have my windows organized on my screen. If you're new to Unity, as a heads up, you can move these around and reorganize the way that you have the different windows situated. I prefer mine the way they are, so I'm going to keep them this way for the workshop. The first thing that you'll want to do in here is target for Windows Mixed Reality. So what we're going to need to do is go into the build settings, and we're going to set that as Universal Windows Platform. Heading into File, Build Settings. For Platform, we're going to select Universal Windows Platform. You'll leave everything on the right as is, and then you select Switch Platform. So by default, the build settings for the Universal Windows Platform, they target any device, and that includes support for immersive headsets. However, you could also select the appropriate device by changing the setting for the target device, which is going to be the setting that currently says any device there. Now that we've switched the platform, we're going to head into the player settings, as there's some settings that we need to do in there for configuration. Within player settings, towards the bottom, we have the XR settings. You're going to want to ensure that that is expanded. And then we're going to need to ensure that we enable virtual reality. So to give you a bit more context around that, so Windows apps can contain two kinds of views. We have 2D views and immersive views. Apps can switch between their various immersive views and 2D views. showing their 2D views on a monitor as a window or in a headset as a slate. An immersive view gives your app the ability to create holograms in the world around you or immerse the user in a virtual environment. Apps that have at least one immersive view are going to be categorized as mixed reality apps. Apps that never have an immersive view are going to be 2D apps. So in Unity, you can configure your project to create an immersive view by enabling virtual reality support. When virtual reality support is enabled, a virtual reality SDK must be added. As there is no separate SDK for Windows Mixed Reality development, the Windows 10 SDK is used instead. So as we select that, if it's not already necessarily selected for you, as mine will be, down here on the right where we have the plus arrow is where you can select that and select Windows Mixed Reality. Mine's already been pre-selected, so there's nothing there for me to select, but if that's not the case for you, that's where you can find Windows Mixed Reality. We now need to configure the settings for rendering holograms. In mixed reality apps, the scene is rendered twice, once for each eye to the user. This rendering method is referred to as stereoscopic vision. Compared to traditional 3D development, stereoscopic vision doubles the amount of work that needs to be computed. Therefore, it's important to select the most efficient rendering path in Unity to save both on CPU and GPU time. Single pass instance rendering optimizes the Unity rendering pipeline for mixed reality apps, and therefore is going to be recommended to enable the setting by default for every project. So down where we have the stereo rendering mode, that's where you'll select single pass instance. Now, as it relates to stabilizing holograms, to achieve better hologram stability from the perception of the user, depth buffer sharing should be enabled. By turning this on, Unity will share the depth map produced by your app with the Windows Mixed Reality platform. The platform will then be able to better optimize hologram stability, specifically for your scene for any given frame being rendered by your app. So I currently have that checked. If you don't have that checked, I'm sure that that's going to be checked as well. Now, with regards to performance, selecting the 16-bit depth format compared to the 24-bit will significantly reduce the bandwidth requirements as less data will be needed to be moved/processed. So here we have depth format. Make sure you select 16-bit depth. Once you've completed that, you can go ahead and click X. For those who are new to Unity, there's no save button here at this step. Once you make the changes, they are 100% saved. Now, as a heads up, before we exit out of here, depending on what app you're creating, there may be some additional settings or configurations that'll need to be done in the publishing settings within capabilities, for example. So if you're following along with any tutorials that we may have in documentation, for example, please be sure that you're following the steps that pertain to this capability sections within the player settings. But for this Hello World sample, we're not going to need to do anything in there. And then you can also exit from here too. Before we move forward, I want to make sure that we do save this project and that we actually do save the scene itself. Should probably do this first, but since we're here at this step now, I'm going to go ahead and do that at this point. So going into File and then Save As, you're going to want to make sure you're in that project folder, and within Scenes, this is where you can create or save the scene, if you will. I'm going to name mine Hello World, and I'll click Save. And so now in my hierarchy, the scene name has changed to Hello World. If you go back to File and Build Settings, at the top we have Scenes and Build. This is where you want to add that scene. So going to Add Open Scenes, that adds it there. This is going to be important later when we build the project before we can deploy it to our HoloLens. So from there, you can go ahead and click the X. So next, we have some different resources that we need to import and configure. Amongst them is the Mixed Reality Toolkit. I did mention earlier that we'll be using the Mixed Reality Feature tool, and that particular tool is how we're going to import the Mixed Reality Toolkit. So first, let's take a little bit of time exploring the Mixed Reality Feature tool and how you can go about getting that. So here's the documentation that we have for the Mixed Reality Feature tool. On this particular page is where you can actually find that download We do have download instructions as well. And once you do that download and unzip the file, you should save it to your desktop for convenience, but you're also going to notice within this file that there is going to be an executable. That executable is what you're going to use to actually run the feature tool. With the feature tool, we have various packages that are available within there, so more than just the mixed reality toolkit. But for this workshop, we're going to focus on the mixed reality toolkit. The feature tool is going to be one of those tools that you cannot use until you actually have your project set up in Unity. So that's why we're now taking a look at how to actually use this tool. So given that we've created our project, we can now actually move into the step of importing MRTK into the project using the mixed reality feature tool. Now, if you download the feature tool and you're in the folder and you're still not quite sure what the executable is going to be, within this folder, there's going to be a file that is called Mixed Reality Feature Tool. The type is going to be of application. That's going to be what you need to select to actually use the tool. So from here, I'm going to go ahead and double click that, and that'll start the feature tool. And here we are. So within here, the first thing you're going to do is click Start. And then for the first step, we need to know the path of our Unity project. So again, this is why we create the project first, and then we use the mixed reality feature tool second. So that path is going to be wherever you have a Unity project saved. So it's very important to know where you saved your project. You can click the 3 ellipses here and then navigate to wherever that might be. And once you've navigated to where that project is, it should be in the directory that contains the entire project itself. So if you see assets, libraries, logs, packages, project settings, temp, that's where you want to be. You'll click open. And then from there, you can go to discover features. So as I mentioned, the feature tool contains more than just the mixed reality toolkit. As you continuously use the mixed reality feature tool, assuming that you're using an updated version, you may have additional packages that are available here. What we need to do is open up the mixed reality toolkit section, and then we're going to use just a foundation package. The mixed reality toolkit actually has a couple different packages available, and for doing any project in general with the mixed reality toolkit, the foundation one is the only one that's going to be required to be imported and configured into your project. And as it relates to versions, you can use 2.5 or newer. So in this case, I'm using 2.6.1 if you're curious. And then from there, I'm going to select Get Features. On this Import Features page, this is where it more or less recaps what's going to be imported. So on the left, we have the feature, which is what I selected, the foundation package. And then on the right, the feature tool pulls in the required dependencies, which in this case, we have the mixed reality toolkit standard assets. From there, I am going to select import. You can also select validate, and that validates if everything's good to go. In my case, it is, so it says no validation issues were detected. If there were issues, you would be notified. And then from there, you'll click import. Here's that final review of everything that's going to happen within the import process. And then from here, you'll select approve. At this point, the project is updated more or less. You can exit the feature tool, and that'll be the last time you need to use that. Of course, unless you decide to import something else for the tool. But for now, we'll click exit, and then we'll open back up that Unity project. So it may take a moment for Unity to import that package. And once it's done, this MRTK project configurator window will pop up. For this particular window, you'll want to go to Audio Spatializer where it says None and select MS HRTF Spatializer. And then from there, you'll click Apply. Once you've done that, you're going to head to the Mixed Reality Toolkit, Add to Scene and Configure, and that's going to add the toolkit to your project. So once the Mixed Reality Toolkit has been added to the scene and configured, there's going to be 2 new objects added to the scene hierarchy window. First, we have the Mixed Reality Toolkit, and this is going to be the object that contains the toolkit itself. And so that object ensures that the headsets and controllers and any other required systems are managed correctly in the scene. Next, we have the Mixed Reality Play Space object. And at this point, you might be wondering, well, what happened to that main camera? So that main camera is now actually going to be a child of the Mixed Reality Play Space object. That's going to allow the play space to manage the camera simultaneously with the SDKs. And the final thing I do want to point out about the mixed reality toolkit, now that it's been imported into the project, is that there are configuration profiles that are available as well. You can access them by going to the mixed reality toolkit object itself. And then just below where we have the section for the mixed reality toolkit, we have a selection of configuration profiles available. So these particular profiles, they configure the behavior of the mixed reality toolkit core components. And so we have default ones that have been created, and the default one that we actually select for you is going to be the default mixed reality toolkit configuration profile. Since I am developing for a HoloLens 2, I prefer to select the one for the HoloLens 2 configuration profile. If you are not using a HoloLens 2, then you can take a look at our documentation to figure out which configuration profile might be best for you. Although you cannot directly change the profiles themselves as they are written or created, if you will, you can instead clone them. And then once you clone them, you can then do all the configurations that you would want on top of the configurations that we give you. So that's something that's very important to know. As you may notice right now, everything below is going to be grayed out. So the next thing that we're going to do is import TextMesh Pro. So some of the MRTK prefabs and assets require TextMesh Pro. And TextMesh Pro is Unity's default text component. TMP uses advanced text rendering techniques along with a set of custom shaders to deliver visual quality improvements. TMP also provides greater flexibility for your text valley and texturing. Also, the TextMesh Pro assets must be added to your project, and you're going to be able to do that by importing the TMP essential resources. By going to the window item here in the menu, selecting TextMesh Pro, followed by Import TMP Essential Resources. This particular window will pop up. You just want to make sure that everything here is selected. If you're unsure, you can select all, and then you'll select Import. Once that import is complete, that is the final step in our setup, and we can get started with creating our scene. All right, so there are various UX building blocks available with the Mixed Reality Toolkit. And although I don't have time to show you a demo of each and every one, we do have a demo package that you can look at to learn more about how the different UX building blocks are configured, and you can try those out as well. Today, I'm actually going to show you how to set up the ability to interact or manipulate with holograms using the object manipulator script, as well as the near interaction grabbable script. So starting here in Unity, I'm just going to use my scene gizmo to turn things in a direction that's favorable for me. Might need to adjust that once we get started, but we'll see. I'm going to create this using a Unity primitive, which is going to be the different 3D models or shapes, if you will, that Unity provides for you. If you have your own model, then by all means, definitely use that. I'm going to use a cube in this particular case. So here in Unity, I am going to right-click, select 3D object and cube, and I'm a little further away from that cube right now. So what I want to do is get closer. Shortcut, if you're new to Unity, is to make sure you have that object selected in the hierarchy, and then put your cursor over the scene window, select F on your keyboard, and that'll get you closer to the object. That's just a trick to keep in mind whenever you're working with however many different objects in your scene. Okay, so from there, the very next thing that I'm going to do is transform the size. So one thing to keep in mind about models, if you haven't worked with them in an engine like Unity, for example, scale is going to be something that's really important to know. Everything is going to be represented based by a meter. So right now, this particular cube that we have here in the scene is 1 by 1 by 1. So that means it's going to be 1 meter in length, height, as well as the depth of it as well. If we were to deploy this and place this directly into the device and try it out, it would be a very large size. So what we're going to do instead is we're going to make it smaller. So for the scale, we're going to make that transform 0.25, and we'll do that for the X, Y, and Z. Yes, it does look significantly smaller now on the screen, but if I remind you from earlier, we can use that handy dandy F shortcut, so that way we can get a little closer to it. And then the next thing that we're going to do is actually push that cube back so that we can actually see it in our view. So right now, you'll notice that we can see the cube in the scene, but in the game view below, everything's still black and you can't see the cube at all. So what's going on there? Well, right now, our headset, which is what the game view is representing, if you will, it's going to be at origin, which is 0, 0, 0, which is the center of your head. Now, you'll notice that for the transform for this cube, the position is also 0, 0, 0. So what that means is that this cube is actually sitting in the middle of our head, thus we technically cannot see it. Instead, what we need to do is push that cube out on the z-axis so that way we can actually bring that into view, and we're going to do that within the position for the z-axis. So keeping the x and the y at 0, we're going to change the z to 0.8, and then now I have my cube in view. I need to adjust where I'm at here in the scene view, and now everything's all set and great. Next, let's add some color to the cube, because right now the default color that Unity gives you, I don't think it's the most flattering necessarily, and it's always great to visualize with some additional added color. MRTK has shaders available, and that's what we're going to utilize for this project. They're going to be within the MRTK package. So if I were to scroll down packages and start to go through this foundation package, for example, I could probably eventually find it. But instead, what I'm going to do is just search in the project window for that instead. So as a hint, all the shaders more or less are going to start with MRTK underscore standard. But if you're trying to find them, type in MRTK underscore standard, and then where it says search, you're going to switch that from in assets to in packages, since this is actually going to be in the packages folder. And then here we have all the different shaders that are available. If you'd rather see the colors versus the name, you can slide the bar over at the bottom of the window, and now we have all the different shaders that are available. I'm going to go with purple for this particular example. And so from here, we can either slide it on top of the cube itself, and that'll make it purple, or we could have also just slid it to the right in the inspector panel for the cube. So now that we have the cube itself put together, we have the color, we have the cube, and now we can add some manipulation with the Materiality Toolkit. So within here, I'm just going to move things over so we can have a better view of what's going on. Selecting the cube, ensuring that the inspector is open, reflective of that cube. And then we're going to add some components. So I'm going to just collapse everything here to get a better view. All right, now we can add the MRTK scripts that were mentioned earlier to this cube, so that way we can manipulate this particular cube using our simulated hands. So within the inspector, you're going to go to add a component. And then within there, we're going to search for that script. The first one's going to be the object manipulator script. This script makes an object movable, scalable, and rotatable using 1 or 2 hands. Now, this script supports direct manipulation input model that we have, and we have more information on all the input models that we have within our docs. But this particular script is going to enable users to touch holograms directly with their hands. And so in Unity, we can search for object manipulator, and here it is. And now that gets added, we have a lot of new things that have shown up here. So let's collapse everything and just open up that object manipulator script that we have. And it gives you a warning here that for near interaction support, we need to also add the near interaction grabbable script. So that is something that we are going to use. So you can either add it manually by going through the same process of add component, or you can select it here to add it, and then that'll add it to the script or to the object for you. So let's collapse all of that, just so you can see here that now near interaction grabbable has been added. So that near interaction grabbable script is what's going to enable you to have a near interaction with that object. And most important, it's going to enable you to actually grab it and do things with that object. So opening back up the object manipulator, we have documentation that goes through what each of these settings are. So for this workshop, I'm going to leave these settings as they are, but definitely spend some time going through how you can modify different parameters that are available here within the inspector for the object manipulator script. So now that everything has been added, we can actually test this out. So before I head into play mode, I did mention earlier simulated hands. So simulated hands is what we utilize so that way you can simulate what it would be like for you to actually interact with this particular object using your hands in real life, but instead you're going to do it here in Unity. Very helpful, so that way you don't necessarily always have to build and deploy to your HoloLens to test things out. You can actually try these things here. There are some features that you cannot try out, unfortunately, within the editor from MRTK using input simulation. One such example is going to be the keyboard as an example. So do keep that in mind if you are building an app that utilizes the keyboard prefab that we have. You won't be able to try that out in the editor. You will have to actually deploy that to your HoloLens to test that out. For the most part, more or less, everything else is fair game. Same as if you were to also enable any sort of voice input or any sort of audio, you can do that here in the editor as well without having to deploy to your device. Okay, so we're ready to test this out, and we're going to use the Unity in Editor input simulation. I'm going to expand my game window so that way we can have a further look at what's going on here. As we go into play mode, I'm going to explain how to use the Unity in Editor input simulation, starting with how to move the camera around. But first, let's head into play mode. And the first thing that you'll probably notice is the diagnostics tool that we have at the bottom of the screen. Very helpful to keep this up while you are developing, gives you an idea of the performance of your app. If you need to disable it, you can also use voice and say toggle profiler, and then that'll get rid of it. If you want to hide this completely from your app, that's where you'll go back to your configuration settings, and I'll quickly show you where that is. Move everything back over here. But heading into Toolkit, and then within Diagnostics, we have a checkbox here that says Enable Diagnostic Systems. You can clone the profiles, clone the diagnostics profile, I believe it is, and then uncheck it that way. So that's just a heads up if you're wondering how to get rid of that. But we do suggest having it open for development. Okay, so moving around in the scene. Right now I'm using my keyboard to control everything. I can use the W key, and that's going to bring me closer. So it's going to be moving the camera forward. This little circle white icon, if you will, that's going to be in the center. If I can get my mouse near it, that's going to be your eye. So wherever that is focused or wherever that is positioned, that's where your eye is looking. That's where the headset is facing. So if you're wondering what that is, that's what that's going to be. So the W key, that's going to move us forward. The A key is going to move us to the left. The S key is going to move us back. And then the D key is going to move us to the right. You can use the Q key to move vertically down, and then the E key to move vertically up. And then if you press and hold the right mouse button, you can rotate the camera. Okay, so that's how you move about the scene. Now, to simulate the actual hand input, there's a couple different options that you have available here. First and foremost, to actually bring the hands into view, you're going to press and hold the space bar to enable the right hand. And here we have our hand. And then while holding the space bar, you can move your mouse to actually move the hand. So right now I have the space bar selected and I'm moving my mouse around to actually move the hand around. And if you want to adjust the depth of the hand, so how close it actually might be to this object, you're going to use that scroll wheel on your mouse. Scroll forward to get closer and scroll back to bring the hand back closer to yourself, if you will. And if you want to pinch, then you're going to use the left mouse button to do that. So right now I'm going to get closer to my object. And if I did my left mouse button, I'm pinching the object. And so now I'm actually able to move it around. That's where that near interaction grabbable is going to come into play. This long white thing you see is going to be a tether. You can disable doing that and instead just have the user be able to actually have to touch the object to move it around. So I'm going to let go of that. And you might be wondering, well, that's a lot of work to keep that one hand up. by holding the space bar, and that's true. So what you can do instead is actually make the hands persistent. So to do that, I can do my Y key, which is what I just pressed to bring my right one up. And then I can also press my T key, and that brings my left one up. So for my right one, I can just drag with my mouse and move that over. And the same is going to be with my left one. I just got rid of it, but you can also move that one around as needed. Now, as for rotation, you can also do that as well, and you can do that with the control key. So bringing my right hand back towards the cube to grab it, I'm also going to select control. And as I'm holding control, moving my mouse around, I can actually rotate that object. So you have quite a bit of flexibility in here for testing things out, all in the editor, but with simulated hands. And now that that's been complete, I'm going to exit out of play mode. And the next thing that you would do if you wanted to build and deploy this to your device would be to save the scene. You're going to build this as a package, and then you're going to head into Visual Studio to build and deploy. So here within Unity, you'll come to File, Build Settings, and then make sure that the scene is in the Scenes and Build section that we discussed earlier. Here you're going to then do Build. Do not select Build and Run. You're going to select Build. And then within here, I like to suggest creating your own builds folder for your builds that you're going to do. You want to select new folder and call them builds. I've never met a person who's only ever done one build. Usually it takes a couple builds before you get everything right. So within that folder, I like to name all of my builds by version names. So I might make this one V1, for example, whatever sort of numbering system you want to use. And then select that folder. Once you've done that, the build process will start. And then once that's complete, a folder will open on your desktop. You can click that solution. It'll open up Visual Studio, and then depending on how you would like to deploy your device or deploy app to device, follow the instructions that we have available in our documentation. And then from there, you'll be good and ready and set to test out your device on your HoloLens or whatever other supported device that you decided to use. I've compiled a list of the resources I've shared with you today in a convenient location available at aka.ms/mr-hackathon-resources. We also have a community within the Microsoft Tech Community platform. There, you can find our forum, announcements, and blogs written by folks here at Microsoft, as well as the mixed reality community. You can access that by going to aka.ms/mr-tech-community. You can also use that platform as a place to post questions and find answers. And finally, if you're interested in receiving the latest on our mixed reality developer tools, events, and early access offers, complete the form at aka.ms/iwantmr. Once submitted, you'll receive an email to complete your registration. Again, I'm April Spate, and feel free to connect with me on LinkedIn. Thank you.
Yay.
That's great. You did a great job. And I'm sorry, actually, with me sharing and video off, I wasn't able to get chat. So I'm just now seeing the chat. So.
Oh, no, it's okay. Doug had asked a question in there, and
Yeah, and I appreciate you asking the response. So I just was
you're
wondering
welcome.
about you mentioned about iOS. Unfortunately, I got to leave now. I have another commitment, but thank you so much,
Thanks,
April,
Doug.
for the overview.
Oh, no problem. You're very welcome.
Thank you. Bye.
Todd, Jeff, do you have any live questions you want to ask? I may have one real quick then, April. And as I said, I'm a novice. So it's a stupid question. My apologies in advance. But you were talking about obviously using the editor to simulate. How does that differ from the emulator? So could someone build to the emulator and have more functionality if they're not actually deploying it to a HoloLens yet?
Even though we have the emulator, we typically recommend using the Unity editor. The emulator, unfortunately, isn't going to give you the best experience as you're testing your apps. And so realistically, I would say with the Unity editor, I mentioned in the video as well, but there's only, I think, like maybe one or two things you can't test out if you're using the mixed reality toolkit. And so that would be the keyboard, because we do have a keyboard that you can implement for typing. And then I think there's one other thing, I can't remember exactly what it was, but I know for sure you can't test the keyboard in Unity. Everything else you can definitely try out. Of course, there's that difference that like it's not in the real world. So there is some guessing that has to be done there. But again, we recommend using the Unity editor. Even the mixed reality team also recommends using the Unity editor too. What I have seen done though is typically to avoid having to do like 1,000 builds and deploy to your device, get as much done as you can and testing out in Unity editor. And then once you reach that point where you do want to build and deploy for your device, then do it. I wouldn't suggest doing it every single time you want to iterate over whatever it is that you're making. I had 2 more points about that. Once you are ready to build and deploy though, I personally sideload my apps. It's just personal preference. And some folks actually do connect their HoloLens to their computer as Visual Studio is doing the deploy. It's really up to you. I don't quite know if one's faster than the other. That's just, again, personal preference. But the benefit to side loading, at least the way I do it, is that you're going to be in the Windows device portal. And so within the Windows device portal, you can also make use of the, oh my goodness, I'm going to call it the wrong thing, but it lets you stream what you're seeing in the HoloLens to your computer screen. So it's like you're testing it out, and if you're working with someone else, or if you want to just, like if you're demoing, for example, what you're seeing in the HoloLens at that same time, that particular Windows device portal is going to help you share what you're seeing as well. So I know that's a lot that I threw at you at once, but hopefully that was helpful with how we typically recommend you approach when you are iterating over that you're creating.
Okay, I think we're right at the top of the hour, and we've got, Jeff's session is starting in about 2 minutes. Yeah. So I think with that, we will wrap up for the night. April, again, I thank you so much for this presentation. It was great. I know one of the question in the chat. Yeah, we will post these live. So if you want to leave it on your Google Drive for a little bit, but I think what we're going to do is post the Zoom recordings out so people could access it that way as well too. So we're looking forward to a lot more people being. I thought it was an excellent presentation. A lot of good material, as I said, especially for someone who knew very little coming in. I felt like I learned a lot tonight. So,
well, good. Yeah, and then since you are recording this, I would say the only other thing we recommend is check out our design documentation. We really like to stress that folks do pay attention to that before they dive into really creating any app. There's a lot of good information in there from a design perspective of what makes the experiences comfortable for users. So I would say check that out. Right. Very first thing you should do.
Thank you. Good final piece of advice to go. So with that, I'm going to shut this meeting down, and then we'll start the other meeting up. And again, April, thank you for the presentation tonight.
Yeah, thank you, and best of luck for everyone. Take care.